This is a quick demonstration of my rotor control program for the Raspberry Pi. It is written in Python using the Twisted library and uses a completely web-based interface to interface with the outside world. It is again on the Raspberry Pi, and you can see that I have an azimuth map on there. That's a great circle map that you can deal with, and that shows which direction your beam is pointed in. You also have a graphical display that displays your heading in numbers as well, and then there are some controls to actually rotate the rotor down below it. So I don't have anything set up to use a real rotor yet, so I am just doing some simulation using a breadboard with a couple components on there and a potentiometer to simulate the rotor turning around. So what you will see is as I start to turn the potentiometer here in a minute, you will see the screen update itself, and this is not using polling again. This is using WebSockets, and there's WebSockets with JSON RPC that's doing all of the data transmission and updating the screen. So it updates more or less instantaneously, and this way you don't have to have a dedicated application. You can just browse to the web page on the Raspberry Pi. Again, it's using Twisted, so Twisted is both serving all of the graphics and the web pages you see on here, and handling the WebSocket calls and doing all the JSON RPC candy that's in there. So you can see that's how the screen can update. The other thing that it does right now is that I don't have a rotor hooked up to it, but if you click on the green arrow that I am here that's pointed clockwise, you can't hear it through this microphone, but every time I click this arrow, then the relay goes, and when I release the button on my mouse, then the relay closes again. So this will eventually be hooked up to the rotation piece of it. It's just using a GPIO pin on the Raspberry Pi and the rpi.gpio library again in Python. So there will be a counterclockwise eventually, and you'll also be able to play around with putting in directly a number to set your controller to go to a specific heading that you want it to go to, as well as I'm going to try and make the map clickable, so when you click on a space in the map it will turn the rotor to that particular heading for you. I'm also going to add the capability to change the beam width displayed of your beam on the cone, and I'm going to add the ability to generate a great circle map based on the latitude and longitude of your QTH. Thanks for watching the video, and please send any comments to me.